The diagram shows the graph of y is equal to f of x, which cuts the x-axis at 1, 0. So we've got a graph of y is equal to f of x cutting the x-axis at 1, 0 and has a turning point at 2, minus 4. Sketch the following graphs, writing down the coordinates of the turning points in each case. So we've got y is equal to f of x plus 1, y is f of 2x, y is equal to f of x minus 2, y is f of minus x, y is equal to a minus a half f of x plus 1, and y is equal to f of 2x minus 3. So y is equal to f of x plus 1. This is a translation of minus 1, 0. So it means every point here will move 1 point this way. So moving each point, so marking on that point there which is on the origin, and this point will become 1 minus 4, and then we can draw the curve like that. So we've got y is equal to f of x. Part 2, y is equal to f of 2x. Well, f of 2x is a stretch parallel to the x-axis, scale factor 1/2. So this point here will move to a half 0, and this point here will move to 1 minus 4. Now, so all these points will be cut in half. So I'll just put these points on here to help me. So draw the graph like that. So this is y is equal to f of 2x. Y is equal to f of minus 2 plus 3. Well, this is just a translation 2, 3. Remember, if it's minus here, it's positive here. So it's a translation 2, 3. So every point, so this point here will move along 2, up 3. And this point here will move along 2 and up 3. And therefore we go to 4 minus 1. And therefore we can join the point up here. So this point here will also move like 2 along and 3 up. Sorry, this point here will move along 2 along and 3 up. So to get sort of the end point. Remember, these are only sketches. So that's y is f of x minus 2 plus 3. Y is equal to f of minus x, reflection in the y-axis. So here's the y-axis, so we'll extend our axis this way a little bit, and we will move this point to the point minus 1, 0, and we'll move this point here to the point minus 2, 4, and we just reflect the graph in the y-axis. Y is equal to minus a half f of x plus 1. So this is a reflection in the x-axis for the minus sign, followed by a stretch in parallel to the y-axis, scale factor 1/2, followed by a translation 0, 1. So what we've got to do is let's just go back a bit. Okay, so this point is reflected in the x-axis that say put. We can't stretch it parallel to the y-axis because it's actually on the origin, but we can translate the point 1, 0. Right, this point here, we got to reflect it in the axis, stretch it. Okay, sorry, so we will reflect this will go to 2, 4, and then stretch it by a scale factor of 1/2, so that will come down to 2, 2, and then move it up by 1 point, so it goes to 2, 3. Right, we can do the same to some of these other points here, and then sort of get the shape of the graph. Okay, the last one's the most difficult, is f of 2x minus 3, because this is like a stretch parallel to the x-axis, and this is a translation. So when you get this situation, you always do the translation first. So translation 3, 0 is represented by the minus 3, and then it's followed by a stretch parallel to the x-axis. So this point here goes to 2, 5 under the translation, and then take half of that, which makes it 2.5 minus 4. Half of 5 is 2.5. So this point goes along 3 to 4, and then take half of that, so it goes there. Okay, and then you could take this point here, 8, it will go to 11. Half of 11 is 5.5, so that will go somewhere around there. Okay, so you can get the shape of the curve that way. Okay, so it's y is equal to f of 2x minus 3. Okay, so this has been a video to show you how to transform graphs using transformations. I hope you've understood, and I thank you very much for watching.